Linda? Good morning, everybody. We are about to start. Please settle down. Linda?
I don't think so. I just wanted to. Yeah. Okay. We'll give her a couple minutes just to. Yeah, I'm not sure the other presenters are ready yet, so we'll give her a couple seconds to figure out what's going on.
Just in case, next presenter, Bovu, are you here? So we could start with second presentation.
Makes sense. Are you prepared to start now? So we'll switch the order of the first two presentations. Okay. Start.
Thank you. Yeah, this one.
Good morning, everyone. I'm going to talk about the SD-WAN VPN service model delivering a draft. And this draft is assumed to define SD-WAN VPN service model. The service model is assumed to be used by service provider to provide to provisioning the CE devices on behalf of the enterprise networks, enterprise customers. And the SD-WAN VPN is assumed to be provide a secure connection over multiple enterprise sites and over multiple WAN transfer connection, and is assumed to be to simplify the management for the whole SD-WAN management. And this draft was presented in last IETF meeting by China Telecom, and based on their development experience. And at the same IETF meeting, in last meeting, ONAG also proposed their open SD-WAN exchange API-based service model to try to solve their problem in the enterprise community. So we think these two models have some relationships. So we try to work on this. And I also presented this drafts in Tuesday Ops working group, and I also got some feedback from their ops working group, and they feel that SD-WAN is the concept that proposed in ONAG, and ONAG enterprise community, and they are the end users of SD-WAN technology. So our model work should be consistent with the ONAG requirements of SD-WAN. So that's the current status of this, of the background of this SD-WAN service model. But right now, ONAG hasn't proposed their SD-WAN requirements to IETF yet. So we just hear our understanding of the work in the IETF related SD-WAN working. So although IETF has defined CE-based VPN back in long ago, and it already defined in RFC 4110, but it seems for now, SD-WAN has more functionality than the CE-based VPN. For example, in Spring working group, there is a draft is SR for SD-WAN. In that draft, it is assumed the CE of SD-WAN could be attached to internet or MPLS network. And the CE can also make L3 to L7 classification. And based on the classification, they can steer the flow of different SLA to different paths. And also in the BAS working group, they are working on the CPE-based L3 VPN so the CE can offer the fine granularity of virtual network separation. And also in security working group, IPsec maintenance, I2NSF, they are working on a new controller-based IPsec VPN approaches to try to solve like IPsec VPN applied to a large scale. So our proposal, yes, the goal of our service model, we try to define a general SD-WAN VPN service model that not only based on the original already defined CE-based VPN, but also has other functionality that just mentioned earlier in the BAS and the Spring working group. They are working on the functionality of SD-WAN. So this is an overview of the current service model we are working on. And SD-WAN VPN could have one or more, two or more sites. Oh, this cannot work. So 2 more sites, each site could connect to MPLS or internet. And in one particular, and in this VPN, there could be one or more sub-VPN that's fine granularity or virtual network inside an enterprise. And each sub-VPN has its own topology, addressing, and policy. And these are similar concept like in secure layer 3 VPN. And the CE can do the layer 3 to layer 7 flow classification and to do the multipath steering. So that's also mentioned in the SR for SD-WAN. This is like to clarify what the ONAC's service model and our model's difference. There are 2 major differences of these 2 service model. The first one is the ONAC try to define the service model used in enterprise network. It means that all the like all the infrastructure. Oh, here. Oh.
You want me to? Oh.
Yes. So this infrastructure belongs to enterprise network, but in the our service model, the CP, they belongs to service provider. So these are the major difference. And the second major difference is the ONAC try to define the interoperability part of this SD-WAN, the 2 interdomain, how these 2 vendor domain can interoperate and intercommunication based on the service model's request. So the orchestrator will send the OSD gateway service to the 2 vendor controller to try to initiate the connection between these 2 network, the gateway. So, but our model is defined for a service provider network, and there also could have some, in some case, there could be also two network have some, like try to provide the interoperability between the two domains. So this is the two major difference. But for now, ONAC just give the two, give their service model. They try to define the reachability model and the path management model. But I think there is a gap here because we don't know, like in a one vendor domain, what kind of functionality that SD-WAN has. So it's not easy to define the interoperability model. So I think the model we're trying to define will help to clarify that part. And I think based on these two input, we can try to define a generic model. So that's our thought. And we trying to define, trying to demonstrate how the SD-WAN VPN service YANG model could be used in ONAP. So that's for reference, that it's used in service provider network to try to create an end-to-end, like the underlay overlay network connection. So I'm here like to collect more comments and feedbacks from this working group and to see whether someone interested in this SD-WAN service model defining work. So thanks.
Linda?
This is Linda Gambard. Thank you very much for the presentation. It's really good. So I invest lots of time in ONUG and ONAC, and I chair one of the working group. So for the SD-WAN part, they basically have abandoned the effort because ONAC, slightly different from IETF, they want to catch the enterprise community's need and desire. And then initially 5 years ago, it was SD-WAN. So they had the SD-WAN interworking group because just like IETF, whenever we do any work, interoperability, it takes very long time. So the patience seems to run out. So now they are all moving to security because for connecting to the cloud, they find out that enterprise today is more about data portability and app portability. And so SD-WAN, it was started as a lower cost, but they find out that they need to reach cloud. So now they kind of swing into security now. So this work in ONUG, they have defined the APIs, right? Yes. So I talked to Steve Wood at last October meeting. He said, yeah, he want to bring this to IETF. I think we should work with them to combine the APIs they define with the data model, so make it align.
Linda, Steve presented last IETF. It's actually work we started while I was involved. So there's kind of work started, but eventually they figure out that the YANG foo is close to zero, so they ask for help. So if we could try to align, probably Steve Wood is the only person you could talk to.
Okay.
There are
for YANG related things, but would be good to align because they don't know what to do.
Yes, yes, thank you.
Would you be able to reach out to Steve Wood?
Yes, I will ask
Great,
Linda to help me to reach Steve. Okay.
And so to provide a little more context, I guess, for others in the working group. So this draft is targeted at this point at the ops area working group, right? That in the title, it's
yes,
the ops area working group.
Yes,
ops AWG.
Yes.
And it will probably, that would be the group. I think that you're at this point, you want feedback from this group.
Yes.
Because we're continuing sort of the focus mini sessions on SD-WAN that were started in last time in Montreal, continuing that. And, so Linda's presentation coming up next is also about SD-WAN. And And so anyways, just providing the context that you're
Okay.
not necessarily trying to adopt this in this working group,
Yes. Mhm.
but it's related to this focus that we're
That the work-
initiating.
Yes,
Yeah.
initiated in this working group. Okay, thank you.
Linda? So and now our goal as IETF here should be to avoid fragmentation and make sure that models defined at different layers interact with each other.
Sorry, I'm a little late, and you start right on time, so unfashionable. Okay, so where's my presentation? Okay, so we present this at IETF 102, and it's mainly about SD-WAN, the problem statement, the motivation, and the gaps. And we had lots of feedbacks for this problem statement and gap analysis. And today I'm going to give some update since last time. Oh, this is still old one. Okay. Is it? Oh, okay. Okay. So, I just start with some key characteristics of the SD-WAN, which we didn't describe very clearly at the last IETF. I think this is the old one. Okay. That's okay. I'll explain it. So, okay. So my update is besides CPE1 and CPE2, I have a CPE3 in there to show that the key characteristics is like between CPE1 and CPE2 on this picture, you may have two different interfaces or maybe more. But unlike the on-delay network where interface, you advertise your property. And here, some of the transport or interface is through public internet, right? So it is local decision on a CPE1 to decide which service to go to where. Like maybe at day one, voice service goes through MPLS network. And maybe at day two, some other service goes through the transport network. And then not showing on this picture is I have a CPE3. And between CPE3 to CPE2, I may also have multiple networks, right? Some maybe provider Verizon, some maybe the AT&T, or some maybe China Mobile, or some maybe the internet. So the key difference is the services putting into the transport are separate. And there's a route definition, like which one goes to, which route goes to which path as traditional network is slightly different from the SD-WAN.
I'm trying to get the updated presentation up, so I apologize for the.
Okay.
Is that reasonable?
Yeah. Okay. So I just start talking. So that there's like another difference between pure overlay is in the SD-WAN, we'll have some interfaces go through the underlay, like traditional MPLS network. Some interfaces go through the overlay, like public internet. And for the overlay, then you need to set up IPsec tunnel. And in the example I showed there, like CPE1, CPE2, CPE3, you could have CPE1, CPE2. They both have public interface, public internet interface. So they could establish IPsec between CPE1 and CPE3. And you could also determine that based on the performance of the network. Yeah, this is the right one. Thank you, thank you. So in this example, like CPE3 and CPE1, they also can have direct IPsec tunnel, but because of the time of the day or the particular traffic, or maybe regulatory purposes, the sum of the traffic has to traverse to CPE2 before you go to CPE3. And then the one key thing is the decision is local. And for the remote side, like same traffic, for example, voice traffic, between CPE1 and CPE2, they can go through transport network 2. And then between CPE3 and CPE2, they can go through transport network 1. So they can go different network. And so the encryption can have an option of end-to-end, CPE1 to CPE3, can have intermediate, like goes to the CP2 through the provider network, and then from CP2 to CP3 through the public, and that's through the encrypted traffic. So that is a key difference between SD-WAN and our traditional underlay network, and also a little bit different from pure overlay. Second part is IPsec management. IPsec has been running over 20 plus years. It's running very well from your PC, from your phone. So, but when the network get bigger, get to hundreds or 200 or thousands, those pairwise IPsec key management becomes an issue. Yeah, in the I2NSF yesterday, we had very lengthy discussion. How do we distribute the key between different pairs? So, and also the key can be set up per tenant or per service, but those fine-grained IPsec tunnel can increase complexity in management, on the key management, because not only you need to distribute the key, you have to manage the rekey, you have to manage frequency difference, so it's quite complicated. So so for the large scale SD-WAN management, the IPsec tunnel, we want to limit it to the transport layer. Basically, only through the public network, untrusted network, you need to do the IPsec. Through the underlay network, you don't. So you could have a traffic between CP1 and CP3. One part is encrypted, another part is not. Okay, so this picture was from last IETF 102. Just to recap, if people were not there, it's basically on the CPE-based VPN. We can have eVPN between CPEs, and that's through the MPLS network. And the same CPE can also have a path through the public internet. So that means the BGP control for the CPE-based VPN has to be able to control both the MPLS network and another instance to manage the path through the overlay. And there's another case of you have two CPEs, they're interconnected by the public network. You set up IPsec tunnel, it works fine. But then when this CPE get changed from, say, AWS availability zone 1 to 2 or to a different region, suddenly the performance get much, much worse. So with that case, that's one of the draft we have in the Spring Working Group to show how do we steer the traffic to the closest PE so the packet can traverse the provider secured and good quality network as soon as possible. So on the right, we added another figure to show that the tunnel between, not tunnel, the network from particular CPE to another CPE in different region, they have different application attached. And from same tenant, some application can go through one tunnel and another application go to another. So we have to tell them this. So there's some gap analysis. We have this tunnel in cap in IDR. That definitely is a very good solution to hop along to do the route distribution, associate route with tunnels. And with that draft, we find there's still something lacking. Like, for example, the endpoint, when they power on, like CPE being powered on, they need to be able to tell the route reflector all the local properties, just like NHRP is doing, advertising what kind of IPsec property you support, what kind of algorithm you support, what kind of duration, and exchange the public key. So that one need to be added to the tunnel in cap. And another one is I call the net property. It's really the private port. So the CPE in the SD-WAN case could have dynamic address. Because it pop up in a shopping mall or at my home. So I need to tell the remote end how to establish tunnel to me. So I call it net property propagation. And this draft, there is a Rosen Best Secure L3 VPN draft. Okay, so that one described that we have a L3 VPN. Suddenly, I put a PE into the remote end, and but that draft assumed the PE in the remote, they call CPE, is pre-configured with IPsec ahead of time manually, and then hand carried to like a hotel room. So everything is pre-configured. They care a lot about how BGP two instances interworking with each other. So that part will also work for us. But in terms of scalability, we need to have a CPE to be able to plug and play. So in SD-WAN industry, the term zero touch provisioning is a must feature, must requirement. Meaning when CPE powered up in a shopping mall, in a hotel room, it has to be able to connect it to their peers automatically without anything. So that gap, that's the specific gap, and also the number of CPEs. Okay, so IETF is protocols, right? Here the draft is mainly talk about the problem statement and gap analysis. And since IETF 102, we put together draft for solutions. There will be different aspects of solutions. As we see in the earlier, right? The SD-WAN is really hybrid of overlay, underlay. Some port interface is underlay, some interface overlay. And overlay part need IPsec tunnel and need to do the key exchange, need to manage the rekey process. And the underlay, you can utilize existing MPLS network. So for the route advertisement, for the transport network establishment, all those need work. So there, in terms of protocol, besides the first draft, talk about data model, right? That's about service model. On the protocol side, there are already two drafts. One is in the IDR, one's in the BAS. And IDR didn't have meaning in this time, so I want to just give a brief overview of that. It's mainly to stimulate interest, discussion, and see this kind of implementation have any flaws, or stimulate other people to come up with alternative solutions. Because today in SD-WAN industry is pretty much single vendor. And the reason for that is everybody claim there's no industry standards, so they just forget about interoperability. That has created lots of headache, pain for the managed service provider. Managed service provider, not necessarily network service provider, they are like kind of managing underlay, overlay, providing CPE interconnection. When they have a network and they put CPE onto the start in a place, like say I put a CPE here, I can utilize both. The biggest headache is if I want to expand my network, if I want to add another CPE, and it becomes very difficult. So by having a standard protocol will dramatically help the SD-WAN deployment. Also for the network service providers and for IETF, be able to leverage what we have, because people can jump over IETF, start with completely new things. So the solution in the IDR, which I presented in the IDR intro meeting, is about utilizing the route reflector as the anchor point for property advertisement. So in this example, CP1 can advertise his port property, right? My port number 1 is MPLS network. My port number 2 is internet. My port number 3 may be LTE. And here are the IPsec property I support from port number 1. And also my local and public address mapping. And then it is up to the route reflector to determine where to forward that, propagate that advertisement to. So in traditional IPsec, like IKE v2, there's a policy database. So each node is provisioned with who you can talk to, right? What traffic is to be encrypted, what traffic is not to be encrypted. And here in SD-WAN is slightly different because the traffic itself can be one moment need to be encrypted, another moment doesn't. And this policy has to be coming down from the controller. And who they can talk to? They can, the configuration of the policy can be propagated to the CPE. But if the CPE is a low cost, like a $1,000 switch, and managing those policy can be overwhelming, especially you want to do the zero touch provisioning. You power up the CPE, you want the CPE to be able to talk to his peer. They have to leverage the controller. So basically CPE1, for example, advertise his property. Here I am, I'm Linda. I need to talk to my peer. And then the route reflector has the configuration. Okay, for Linda, I can only talk to Jeff, but nobody else. So he will propagate that property to Jeff. And then for the tenant 2, they do the similar thing. So that's the tunnel advertisement policy being determined by the route reflector. And here's the extension for the tunnel in-cap. So one thing is about IPsec. So the IPsec itself, we leverage the information needed by IKEY, but the transport route is different. Instead of going to my peer, who I need to talk to, I send to my controller, and the controller will help to send it to the tenant. There's another extension needed is for the net property. So as a CPE, I can request from my local down server to find out who is my net provider and what kind of net property my net device provide, and then be able to tell my remote end, I'm a private address, here's my net property, and here's my public interface and public port. So those TLV are needed for the tunnel in-cap. And on top of that, because SD-WAN itself is kind of hybrid overlay underlay, those transport network need to be established prior to data arrive, prior to associate with any particular service or routes. So in IDR, we requested a new SAPI. It's really to advertise, this is my SD-WAN, and here are my different type of transport network. So that's the extension we have done. So next step, we want working group adoption. And since we have got lots of feedback, and main reason for working group adoption, so to tell the world, IETF has this work. We have identified the problem statement. We have identified the gap. And here are some of the protocol extension we can do to enable interoperability, to be the first one to break this chicken and egg problem. Because industry, when you go to the managed service provider, vendor will tell them, there's no interoperability, just use my solution. Nobody else can plug in. And there's no industry reference on that either. ONUG is trying to tap on that, but they don't have the expertise. Seriously, they don't have the expertise. They talk about use cases, they talk about requirement, and they talk about API. That's pretty much the expertise they have. And IETF is the place with expertise. And make this working group draft. They will attract more vendors, more participants come to give comments. And that's it. Thank you.
This is Dino. Your comment about ONOG. So yes, they want to come to the IETF for solutions, and a lot of people have done a lot of hard work to make that happen. However, if the IETF comes up with too complex a solution, they're going to go elsewhere, or the vendors are just going to do it themselves. So you have to be able to articulate extremely clearly to these users what the solution is going to be.
That's well taken, yes.
Hi, Rtgwg. On the gap analysis, at the last meeting, we talked about RFC 5566 having provided some possible capabilities and solutions. Did you take a look at that? Where does looking at that stand?
Okay, I took that out because after IETF 102, many people come to the comments saying that has been obsoleted. We shouldn't use that as a reference. And with that, I'm taking people's opinion, so we take that out. We're using the tunnel in cap. And we want to, however, we do want to be able to, for the controller to be aware of all the possible transport networks there are. Some of that underlay, some are overlay. They're different from tunnel. Okay, tunnel is end-to-end. This is talking about particular segments of the SD-WAN.
The NCAP SAFI certainly can support it, support segments. It doesn't know about the application, it just knows about tunnels. So how you use it is your call. I was involved with deprecating that. In fact, I advocated it since we were the only one who implemented it and thought it was too complex. But that was because there was no use case. And if you think your use case is it can be solved by something we've worked on before, it's better to use an existing solution than to go through the process of defining something new. So I encourage you to look at that, and if it meets your use case, use it. If it doesn't, maybe look at what we ended up replacing it with, which was just the way everyone effectively used it, because it's a lot easier, which is the NCAP attribute. Figure out how to extend that or use that. And
I'm so glad you gave that comment. I'm so glad you gave that comment. I've been puzzled by this. I'm puzzled by this, and IETF can create an RFC, and a few years later saying that's not valid because nobody's using it. I myself, I've been puzzled by that, but everybody's telling me don't fight.
Well, we updated it based on implementation experience. The experience is that we could use it in two different ways, and one of them we found to be overly complex for our use cases. And given that there was two ways and one was overly complex, we went with the one that was simpler. Now, this is a different use case.
Okay, so for the tunneling, for the 5512, I want to separate between tunnels and the transport, right? So in SD-WAN, we're talking about transport, the interface, the transport. The tunnel can be between CP1 and CP3, but the traversing can go through different networks. So that part, even 5512 is not covering that. So that can be extended. We can talk about that offline. That'll be great. Sure. If you can join the work. And
yeah, that would be great. 5512, you can actually support stacking of tunnels. It allows you to do that. It sounds like that's what you're doing here. Maybe I'm misunderstanding. And so we can talk offline. That'd be great.
Okay. I'll talk to you afterwards.
Wim Hendricks, Nokia. Is the two gaps which you identified so far is mainly about IPsec tunnel establishment and the NOT traversal? Are those the two main gaps?
There could be more.
Okay,
those are the ones I wrote in my draft, and I'm looking forward to more feedbacks, more gaps. Actually, in the draft itself, I probably didn't describe very well. I heard some comments that this particular part wasn't described very well. So that's something we, if adopt to the working group draft, and they'll get more feedback on that.
Because I as an SD-WAN vendor, so you actually, there is way more gaps than what you actually have identified, which is, I think, I do agree. So for IPsec, there could be some, it would be good to help supporting setting up the full mesh and stuff like that. I think we don't necessarily have to reinvent IKE, in my personal view. I think it's good that BGP could help in making available which endpoints needs to be set up with a full mesh or with a hub and spoke type of topology. But we don't have to reinvent IKE necessarily to do that, right? Because you can assist basically the IPsec process to say, okay, to which endpoint you need to address, and then still use IKE to do the IPsec establishment, because then you get all the rekeying and everything available from those protocols for a while. I do believe that for NOT, there could be some extensions which are useful. I'm not sure whether defining a new SAFI is actually the right way forward, but that will be a discussion in IDR.
Yeah.
But I think where there is definitely another area which potentially we have to focus on, but it will be a very challenging one, which is everything to do with load balancing. Some people use packet-based hashing. Some people use flow-based hashing. They use latency measurements to actually figure out what is going on and how to optimally use the available transports which are available to them. And that's another huge area which is not so easy, I think, to address.
Okay, thank you. For the IC, we had like more than an hour discussion in the I2SF working group yesterday. So for the IC itself, the content we don't change, but how do we set it up? So in I2SF, we identify 3 cases. The first case is controller facilitated configuration, because for IC, there's lots of configuration, right? Policies and SPD, SAD, and not SAD, SPD. Second is second case, which has a lot of controversial, is actually controller for the CPE, which is low cost, low power CPE. They don't want to deal with communicating with so many peers. So they depend on the controller to help them to do the key propagation. That one created lots of issues. And third case, and Dave is in the room as well. So he proposed the third case is controller facilitated IC. So controller facilitated IC means, for me, I don't have to talk to everybody. I just send it to my controller. My controller determine who do I send to. And then we need to establish the key.
I think we agree that there is a problem to be solved, right? I think that it's semantics on how to do it. I think it's where we need to have more discussions probably. Right?
Thank you so much.
Keyur Patel, Arcus. I just wanted to remind you, basically, you and I had conversation, but was just updating Lou. It is his RFC 5566 that we are updating and ensuring that it goes over tunnel length caps. As an author of a tunnel length caps, I'm updating both the RFCs. So I just wanted to let you know that work is going on. Happy to work with you and cover this.
Okay, that'd be great. Thank you. So that's more reason to make it a working group draft. So we can have different draft in different protocol working groups, right? So RTG working group as the head of everybody else.
I've got comment for you. Nevertheless, so I think when you have BGP, when you have a hammer, everything looks like a nail, right? We really need to find right boundaries between management plane interactions versus control plane interactions. You shouldn't be doing everything in BGP just because BGP is there. We have BGP less for that, right?
Okay, so that's another issue. Really, for us, we want something simple, right? In our deployment today, we first release was using NHRP, DSVPN. We deployed that for SD-WAN. But we start to find problem when the number of nodes start to increase, more than 100, it start choking, doesn't perform well. And since BGP, everybody here, right, is widely deployed. Everybody has it. Even go to AWS, they don't implement any protocol. They support BGP. So because of widespread, just like IPv4, right? Everybody's saying, don't improve IPv4. We have IPv6. But that's there because it is there. So we just add something, we make it work. Because from any vendor, they want to deploy it as fast as possible, as simply as possible.
I was talking about right decision from an architectural perspective, not necessarily, again, just beating up everything with BGP.
This is really an example solution, just like IETF process, right? We need to show the problem, the gap, and the example.
So if this were to become a working group document, you'd be very open to whatever other suggestions people have about
Absolutely,
that?
absolutely. Okay. And also the solutions can be in other working group and doesn't have to be here, but here is mainly to identify the problem, gaps, and stimulate other working group to work on, right? Yeah, the manager.
Keyur Patel, Arcus again. If you're looking for a solution outside BGP, there was a draft which expired in CARP working group that was a generic draft that allowed two endpoints to exchange keying materials. Maybe you can use that. But you know, they say when you can't fight them, you have to embrace them or join them.
Thank you.
So yeah, one more question from
Just really brief. There's the Lisp cryptograph where you can negotiate keys without a key management system. So look at that draft to do encryption in the data plane.
Okay, without key. Okay, like SSL, right? I can reach my It's not okay. We can talk offline on that. Okay. A Lisp. Okay. Okay. Actually, Lisp was proposed as another alternative solution. Rtgwg, he said, "Why don't you use Lisp?" I said, "Well, maybe you should have a draft on Lisp. How to do this?" What?
Why didn't you mention it?
Oh.
If you're open to other ideas like he asked you, why didn't you mention it?
Oh, well, I can mention, but I didn't have a draft. I didn't have a solution. Our implementation hasn't covered that. So whoever want to implement, they are the one. They should burden this on their shoulder.
So, so we'll cut the specific discussion about the draft right now, unless you had another comment on this aspect.
How many of you have read the draft? It's pretty good. Who thinks routing working group should take on the problem space and continue working on it? Besides Andy? Okay, thank you.
Thank you very much.
Yeah, well, let's continue that discussion a little bit since we have a pretty open agenda today. You can go and yeah. I wanted to phrase it also. So this topic seems within scope of the broad scope of Rtgwg, especially these two documents are informational. Seems like based on the feedback that we're getting, at least it's the right venue, right? That people are interested in this topic. So let me phrase it the other way. Is there anyone who thinks that we shouldn't be working on this topic? That it's just want to take advantage of, FaceTime to get any feedback. Okay, thanks.
And last comment, as if you start working on it, please keep it synced with data modeling work as well, so they both progress.
So next up is Donald Eastlake, talking about explicit topology marking in RFC 8377.
Okay. So I'm Donald Eastlake with Huawei Technologies. This should be a pretty quick presentation. Just wanted to make people aware of something which was specified in RFC 8377. So I usually use very simple slides, but I was getting a little tired of all this horizontal text, so we have some angled text in this one. So some people understand multi-topology. The idea is to specify really a physical subset of the resources so that links and nodes are marked as to what topologies they can handle. And that implies also that the packets you're trying to route are classified into those topologies. And so a router, when it receives a packet, has to be able to figure out which topology it's in so it can know what to do with it. And this is traditionally determined by some combination of the port on which the packet arrives and various header fields that already exist, like VLAN or some bits from the IP address or a type of service or who knows what. So you might want to be able to explicitly label packets as to what topology they're in. So RFC 8377 specifies a way to do that using an Ethernet tag. So there has been an ether type assigned for this. I guess it's 9A22, a little hard for me to see. And the initial specification for this, there's a version and some reserved bits and then 12 bits for the multi-topology ID using the ID space from the ISIS multi-topology RFC. That's probably fine for ISIS and OSPF. The OSPF has, I believe, a smaller multi-topology ID, but you can just leave the upper bits 0 for that. If somebody wanted to specify some use for those reserve bits, they could, I guess. The RFC 8377 explicitly says that this tag can be used for other protocols. It was defined in connection with Trill, but it's available for people to use. And if for some reason you need something even more different, you could use the version field, which is 0 in as defined in 8377, and have some other value. You really shouldn't probably change the length of it, but I guess you could if you really wanted to. So I just wanted to make people aware of this, and hopefully now at least the people in this room who are listening are aware. Any questions?
We are trying to download the links rather than.
Okay, thank you.
Wait, I think we ended up in the same place. Okay.
Okay. This is Romin. So I will introduce this side meeting of the network wide protocol monitoring, which hold this Tuesday. Okay. Oh. Okay. Everything done. Okay, so here, why we here? So this is the in IETF 102 in Montreal. That's we propose one protocol is the net for the network monitoring protocol. Here we propose the protocol to monitor IGP for network troubleshooting. After the submission of this draft, we receive a lot of comments and have a lot of discussion through the mailing list, and also in the presentation in IETF 102 in group working group and the OPSAWG working group. So based on this, the feedback in after IETF, so we go on to identify the possible use cases and also the do the gap analysis on the existing tools and investigated the existing control plane telemetry tools and methods. After that, we propose this the possible framework for the control plane telemetry for network protocol monitoring. This is for the most use cases is for the network troubleshooting and the network planning. We are propose this framework instead of directly propose defining the protocol. So this in order to collect the feedback and have to see if we can reach some agreement or some the consensus. So IETF 103, we organize a set meeting to discuss the problems, use cases, and the requirements, existing tools, and potential solutions. So now that this is for the summary of this set meeting. Okay. This set meeting, we is honored to invite many routine experts and the operation experts, and so that's almost near 20 attendees for the set meeting. And also a special thanks to the individual for feedback from Benoit, Paulo, AC, Jeff, who can not get the time for the set meeting. Okay, so I think after the set meeting, from my point of view, we received the extensive feedback on this work. Okay, thank you all time and the valuable feedback to help on this work. Okay. So this is the brief introduction about this work. Yeah, in the NTI, in the OPSAWG, we propose the network telemetry framework. So we classify the telemetry work for the data plane and the manager plane, and this is the control plane. From our point, that's in the past years that the manager plane, a lot of young model is being defined, and the extension of the netconf or the gRPC is being proposed in the industry, has been well accepted. And for the data plane, this is the telemetry. So the in IPPM working group, so the in situ OEM work is being proposed. So we think that is for the data plane telemetry is ongoing. So now we think it's the 10 for the control plane. For in order for the network monitoring, so we need some protocol to collect the more control plane data
for the network troubleshooting or the network optimization. So we hope to see what's the consensus on this possible the protocol choice. Okay. Okay, so this is the problems. So I think this we are very familiar with our IP network. So this is for the network troubleshooting. So that is a lot of these issues is caused by the failure of the routing protocol. So this is now that is very take a long time for some of these the issues. Network failures may take a long time and must the very experienced engineer to locate the root cause. So this is one cause for this work. And another is network planning. So now that's either for the 5G or say some of these the new applications, they need the real-time network planning. So this need to collect the network states in the live network and do the network planning in the real time. So this is the cause for this work. Okay. We identify the possible use cases. So we give this the typical cases that is harder to be located for the network troubleshooting. This including the root loop and the root flapping, and also the LSDB synchronization failure, and also some of this PE tunnel failure. So this is the use cases. These are general the characteristics. So that this is a network wide failure instead of a specific device failure, because this failure they must to comparing the data between devices among the in the network instead of directly log one devices to locate the root cause. So this is the typical case for the network troubleshooting. And then this is the network planning, the use cases. This including the root path optimization and also the root policy validation. So this is means we collect the network real data for the simulator so that it can validate the new root policy to see if it does work and see what effect on the existing network. So this is the use cases. Okay. Out of these use cases, we abstract the general requirements. So the first, this is we need a tunnel for the control plane data exports. So this we need a valid way to export the required control plane data, and also the export performance must satisfy the requirement of the collection. So this is the first one. Second one is the adequate the protocol data collection. In fact, there are already some existing tools to collect the protocol data, such as we use some this the netconf or use some gRPC to collect the protocol running status and also the operation data. And also we have the BGP link state to collect the network topology. So this can be used for the protocol, this used as the protocol data. After the use cases, we identify more data for the protocol should be collected. This included the protocol PDUs, such as the SS LSP and OSPF LSA, and also hello open update. This is the messages of the routing protocols. And also we need some this network-wide the RIBs, and then this is the policy, and also this is the correlated record of policy and the route. So means we not only to export the route, but we also propose this the route experience. What's the process has been defined by the policies. So the correlation should be exported so that if we get this information, so we found that this failure here happens, we can know what policy cause the root failure. So this is the correlation we think is important data should be collected. Okay. And then this is another is network coverage. So this is means that is need to collect multiple devices for the routing data. So that's you set up a network-wide the protocol data. Yeah. Okay, so this is the summary of the set meeting. So this is the summary is like this one. The use cases identify real problem in the live networks. Yeah, so that's one. The second one, the operators use a variety of existing tools to extract the data they needed. That means especially when the failure happens, they will try all possible the tools to extract the possible data for the network troubleshooting. Yeah, not only the existing tools such as the netconf, CRI, and the BGP link state. Yeah, but maybe the for example, even know the protocol data to be for the protocol data to be exported, they can use some of this the mirror. That means replicate the protocol data and to collect it from the devices to the network analytics. So this is also some of this the tools. So that's thanks for the attendees. So they propose this the more existing tools for help us understanding the existing network. Okay. After that, we get some of this refer consensus. So that is the first one. This is there are missing models, and the models already existing are not complete for the network troubleshooting or the network optimization. This is truly exist. And the second one, they think the streaming telemetry is the potential generic solution for the new data type collection for new application. So because this is in fact in the last IETF meeting, and this that is the most debates is the protocol choice, because they think maybe the streaming telemetry, maybe the extension of BMP, of maybe the extension of the BGP link state. But after the set meeting, the discussion, they think that maybe the BMP is already adopted in the existing network. So this is the reality. So this is only for the so this is only used for the BGP. For the BGP, if we go on to collect some of the data for the IGP, for the protocol data, they all they prefer that the streaming telemetry is adopted for as the generic solution. So this is the consensus. And another agree that is because the network operation, when the failure happens, so they must use all possible tools to collect all possible data. I think they cannot wait enough time for the standardization. So this is seems that standards always lag behind of the operation applications. But in order for accelerating the process, they think the open source will be much helpful. So this is the rough consensus of this set meeting. So after this the set meeting, so we think that the possible work to do the next, so that is the more use cases identified. That is hard to detect or locate. So that is based on this one to identify the requirements on the new data collection for the different use cases. And last one, so that if we agree on the stream telemetry is a generic solution for the future, so maybe this is the new young models standardization work will be proposed in IETF and the open source. Okay, so my point of view, I think that is we after that we achieve our goals to collect this the extensive opinions of the experts in the industry. I also would like to say that this is a rough consensus. If you have any comments, I also have an opinion on this one. I would like to collect more comments based on the, yeah, okay, take this chance. Okay, thanks.
You want to go to the mic?
Okay. Okay.
So I think one of the main consensus that isn't directly stated here is that of this side meeting that you referred to as that Chris Bowers speaking, is that we don't necessarily need more protocols to do this. So the name of this project that you're working on, network monitoring protocol, is a little bit leads you to think that it's a foregone conclusion that we need more protocols to do this. And I think the general consensus is that we don't need more protocols to do this. I guess you refer to, sort of new use cases using streaming telemetry. So aside from that, though, I was thinking that the network operators represented in the IETF and in that discussion are, the operators running the largest, most complex networks in the world. And there's a whole class of other operators that aren't represented at the IETF because they don't have the resources to come here. But it might actually be useful work, and I don't know where that work would be done, to sort of define for your use cases what actual subset of data do you need to troubleshoot them, so that maybe those operators could take that, I don't know if you call it a template or whatever you want to call it, that subset of data, and at least request that their vendors provide that subset of data so they can then either build a tool or buy a tool that does that. Because I think, a mid-sized operator looks at the thousands of pages of Yang models and has no idea what to request support for. And they're just going to be sort of at the mercy of what they get. So that might be sort of useful work to help address these use cases for the mid-sized operators, and larger operators would also benefit from that as well. So that's just my feedback.
Okay, thank you. Yeah.
So just answer abstract. So the fact that there are three things: data transport, has to be asynchronous, binary encodings, gRPC and Yang push is there. Data consumption, so how you model it, and Yang helps us. Data correlation, this is more interesting topic, and there's still kind of wide area of applicability. How do you correlate events? So this is interesting space to work on. There's a lot of stuff out there that you didn't mention. Hopefully Rob will mention some of them. I don't want us to reinvent the wheel. We need to focus on what needs to be solved rather than reiterating what has already been solved. So you mentioned some tools, you did mention some others. I think we need to kind of look wider, what's available in the industry, what OpenConfig is doing, has been done in NetMod, NetConf, and actually BGPs and IGPs working groups where we define data model that also provide operational state. And I'll let Rob.
Okay.
Rtgwg, Google. I have some experience in this area, as Jeff just hauled me up to talk about. So we've been working on this for a bunch of time. I think the observation that we don't need another protocol is key here. We've kind of defined some transports, as Jeff said. We've been working on that as gRPC based with a way to be able to have modeled data that doesn't need to be modeled in Yang pushed over it. So that I think that this moving towards a single solution is the right thing. And then there's two bits of work that I think that are worth commenting on. One is what set of data do we need? I think it's an interesting problem to go and say, okay, what are the things that we can export? What's the performance? What's a performant way to get it out of the device? What's the encodings needed? We've done a bunch of work. There are shipping implementations of LSDB streaming, for example, over gRPC, over GNMI specifically. So we've kind of started to solve some of these problem spaces where they're not traditional monitoring data sets. I think you'll find that most large implementations, or implementations that that are widely adopted have some roadmap to getting a decent amount of the operational state that we currently collect already. There's, to me, a problem space around what additional data haven't we identified. I think some of that was what the point you were raising, basically, what instrumentation do we need in an implementation to be able to debug it? I would encourage a conversation with operators rather than a specification to operators, because I would say that the expertise for operating a set of boxes plugged together is probably not mainly in this room. Let's go and talk with folks and figure out what they currently do, how they currently debug things, because this isn't, debugging network problems is kind of bread and butter. The other area that I think is interesting is this medium operators problem, right? So yeah, I have a software engineering team that I'm part of that we're writing implementations. We have a bunch of resource to put on this. Other operators maybe don't have the same expertise. The challenge there is that I don't think, blueprints are the right thing. It's got to be running code. Like we need to get this kind of modern telemetry data at the stage of like MRTG is, where I can download something. There's a bunch of tutorials online that tell me how to get the thing set up and have it go from data collection to graphing. And right now we've done a lot of work in the device-facing bit. So we've open sourced a collector, we've open sourced test frameworks around the data from the device. I think there's then the next layer up. So Yahoo Oath recently open sourced Panoptes, which is their kind of next layer up. I think we should concentrate as an industry of getting this stack kind of stood up and show how to adopt this stuff for those operators. That's the thing that will make things go quicker. It's not necessarily standards documents or deployment documents.
Okay.
So,
Thank. Okay. Yes.
I don't always agree with Rob, but when I agree, it's completely. So, golden board. This is really what I think, and I'll let Chris comment, should be the focus. This is a problem that hasn't been solved. Gathering LSDBs has been solved in a variety of ways. Streaming LSDB stuff is coming on pretty much every implementation. Data model is available in OpenConfig. So it doesn't make sense to reiterate on things that have been solved. Let's focus on things that are not.
Okay. Yeah. Okay.
Jeff, just for the minutes, did you agree with me or disagree with me?
I did agree with you.
Okay. So thanks again. Okay, we will act the comments collective this one, and we go on to co-work with other community and have more investigation of other operators, and to try to go on this work and this topic. Okay, thanks again for your help. Okay,
Robin, so the focus is to work with operators, people who consume this information, to identify missing pieces, not to build a new protocol. Correct?
Okay. Yeah, I think the streaming telemetry maybe is the protocol. Yeah, not the new protocol. Yeah. Okay.
And actually is a rather good lead-in from Rob to this discussion about using open source tools for network management.
Hi, my name is Dan Bogdanovic, and I will just give you a quick overview what open source tools are available, and at the end, a quick example how you can use them in the open source routing environment as an example. So saying that, this thing is, okay, that's fine. Okay. So when you're looking at the network management, you need essentially a transport, you need essentially a data modeling language, ideally, that you can use for representing the schemas that you want to use, as well as you need some central database. And there has been on and off in the past 10, 12 years have been different open source. Now I need the sunglasses, from Rob Shakir. So and there has been on and off the open source tries that come out, but finally there is a solid open source implementation out available, and this has been driven by a group from Czech Republic around, like CESNET. They have developed libnetconf and libnetconf2. They are, right now we can say they are mature implementations that, and you're getting a library that you need to build a, client and a server. So the NetAppear guys started it, and they started it, as said, in 2006 or 7, and since then 2 implementations, came out. One of them is libnetconf, and the other one is libnetconf2. The main difference is that one is using the libxml, and the other one is using libyang. The other part also is that the libnetconf is not maintained anymore, and the new focus is being done in the libnetconf2. If you would have used both, you would see a significant difference, in the performance as well as the resources that are needed in order to run it, in your application. So here's a quick, overview to see what is supported, and it's as I said, it's a mature implementation. It is well used. We have tested it in in different environments against different vendors, and it works quite well. And the community, as said, is actively working on that. So the next one, what you need is a data modeling language, because you don't want to code directly and represent your essentially schema in the code. So with Yang, you can essentially compile the schema that you need, and you can update it much quicker in order to advance your project. And libyang is a very useful library, especially if you're planning to implement some of the existing models that are available out there, being they're either from the IETF or from other organizations or open source projects. The library is, again, you will see on the next page, is it's well mature, and it allows you to load and validate the Yang schemas and data into your daemon that where you want to use it. It supports Yang and Yin formats, and you can do the XML and JSON representation. As you can see here, as you can see here, most of the RFCs that are well used and that you need today are supported, and the parsing of the schemas is, based on our experience so far, is really well done. And the nice thing is also what I will talk a little bit later in the context of the FRR. You can do some interesting Yang extensions using the libyang. So now you have a transport protocol, you have a data modeling language for representation, and you need a centralized management data store. So
can I just add to the previous ones? So,
sure.
I'm Rtgwg from Google. You should be tired of my voice by now. So this is useful if you want to output C, right? There's not. We've done some other work in this area just to add to the collective open source in this area. We have a library that does from Yang to Python class bindings, which will do a similar set of functionality here. We also have written a relatively fully featured Yang to Go structs library that's also open source under OpenConfig. It's called YGOT. That library also does Yang to protobuf, which then gives you a bunch of other language bindings that you can get. It doesn't have the same validation, but at least lets you start dealing with the schema. And we've been using these with various other implementations that run libyang.
And protobuf to Yang?
Yang to proto.
And
no, not the other way around. No. So we don't take a proto and generate Yang from it, but we'll take a Yang model and generate a set of protobuf messages from it.
The FRR folks were using the tool, and you will see that mentioned a little bit later. So
would you please send the list you've mentioned, list of tools you've mentioned to the list?
Sure.
Thank you.
Damn it. So this is, so once you have the the transport to communicate to your application as well. You have the language to represent the application. You need a centralized management data store. And this is one area where many vendors, they have their internal management daemons that are, connecting the internal daemons to the external world. And this is where you can use sysrepo. Sysrepo is again, mature, and we have the representative in-house here for the sysrepo. It's an open source one. There is an open binary to be used that I will be mentioning later. But with the sysrepo, you're getting the full Yang support that you need. And essentially, you have the ability to store and retrieve your Yang model data from all your different daemons that are using it, and you can use it essentially as a centralized configuration store. It just provides you the regular management features that many people take for granted, but you don't have to do a lot of implementation. You can take it and be pretty quick to a startup, where you can have the startup running and the candidate data store support. I was trying to find out the plans on the NMDA implementation. So,
Michael Rubens, yeah, we're looking into that one. And I also want to add, I don't know if you're saying this, but this is SESnet that also does LibYang, and NetOpere is also involved in this project. So we consider that like a suite of so sysrepo as a configuration store and NetOpere as a netconf server go together.
There are publicly available tutorial how to bring them together and make them working.
Yes, so sysrepo.org that has everything, and there are Docker images and everything you can play with, and we have Ubuntu packages. A lot of it should be fairly easy to get going, and if it's not, we'd like feedback on that.
Thank you.
Again, sysrepo provides the data consistency and constraint enforcements according, to the Yang models, which is, an important function, and it allows, the validation of your high-level configuration across, the system. So there are some nice, implementations about the details of the sysrepo, and one of the things which I like to point out at the beginning, it's no single point of failure design. You can really have it, you can restart it, and you can just continue where you left off if your transaction was completed from the previous time. And also it has the full transaction and concurrency support. You can find out more about it, but it has support for several languages, and it also supports the NACM model. NACM is if you want to enable a multi-administrative, multi-user system, this is the one area where it comes in useful. Now you have the data models, and you really have to validate and transform the data model into the schema. Pyang is a useful tool in order to do that. It's been very stable, and the community, actually more or less few people, have been keeping it up to date to the latest IETF spec. And if you're planning, to do any work, this is what you can give to your network developers, the ones who are coming up with services, to validate, if what they are doing is correctly, or to the developers if they are trying to do a transformation between the existing model and the Yang model in order to verify if the schema has been correctly generated. Again, here's the quick overview of the supported RFCs, so you can always make sure that is there what you need and it's being done according to the standard. Now, the tools are available, and the question is, well, how we can use them, and why do we really need them? And one thing which I find it interesting is that instead of writing bunch of code to represent your schema from your daemon, and then every time when you add some new functions, you have to write, the code in order to generate the schema. The Yang gives you a higher level language that can be represented and then translated into the code. This will increase your development speed. Now, you don't have to use Yang per se. There are other data modeling languages that are out there to be used. And to be honest, in the FRR, we are using Yang, but we were also using, the Google protobufs, et cetera, in order to provide, the needed variety. And with this, but you need a management entity and a central data store. If you have one already, that's fine, but there's one to grab, on the fly. And if you're using sysrepo, providing feedback, I will just now be the open source evangelist and say, at least, provide the feedback of the testing and the use cases that you have found that are working well and that are not working well. This is a tremendous input to the community in order to continue developing the code, because it gives, the corrective actions from a wider perspective. You also need a protocol to communicate with the external systems. libnetconf 2 is a stable one. It gets connect you to multiple existing commercial and open source implementations as well. Then you can export your data model pretty easily and and make the integration with the other systems on the network much more easier. Before, actually, it wasn't hard to build a product. It was hard to integrate the product into the existing management systems, because there was a lot of CLI, screen scraping, and using the expect scripts. And every time when the CLI changed, and they love to change the CLI, your network management integration code was breaking. So by having those open source tools and being a standard, it's much more easier to do these network management integration. So, So in the example of the free range routing, how the daemons were managed. Before, there was a CLI VTY shell, which was a centralized interface into the daemons that were part of the FRR. So you would have a central place, but you were communicating from there to each daemon independently. And each daemon had its own schema that was essentially hard-coded into it. And that was a problem, because here, adding of the new functions, features, and the management process of those new functions was rather complicated, and putting some service level features, service level applications on top of that was hard to do, because there was some cross daemon verification missing, and that wasn't an easy way to be done. We realized that it has to change, and the project has been started to create a new northbound architecture. And the FRR team decided to do it in a few ways to show the different possibilities and how it can be used. It was, some open source as well as some open binaries or free binaries, and show how this can be integrated. In this case, you have also an adaptation layer. Where's the... Oh, this one. No, doesn't work. So in this case, an adaptation layer would have to be created between the libyang and the existing existing management layer, because that was needed in order to be able. That's an in-between step, but some of that adaptation layers that if you're starting from scratch, you don't have to worry about the adaptation layer. But if you have an existing system, you might have to look into it and see how can you create that essentially translation from your existing schema into the Yang schema and then export it. You need then a communication mechanism, and this is what was done through the IPCs, that each of the daemons will communicate to the centralized management daemon. And the FRR community decided to leave the CLI VTY shell in place for the backwards compatibility reasons. But the idea there is to show also how you can use a new management daemon like sysrepo and essentially connect it into into that. And for that, the Google protobufers were used in order to connect, and the Google protobuffer interface was created for each. Well, I'm not sure if for every interface is already created, but there are bindings in place and available in order to do that. The communication through the internal systems between your management and the daemons in place now, you have to use a transfer protocol to communicate from the internal, essentially to communicate from the internal daemons to the external world through that. And this is, for example, in the sysrepo, you would use something like libnetconf, and in the daemons, you would use something like libyang. And in the next slide, you are seeing essentially the internal view of an internal daemon and how the implementation was done. So the idea there is that you will have a young module for the daemon that provides you certain functionality, and those functionalities are being described in the model, and you are then using some kind of another, in this case, IPC mechanism in order to communicate to the management daemon. Now, if you want to add some new functionalities, the update of a data model is much more simpler, because you get the code automatically generated and is being then updated and is being tied into the new functionalities that are being done. It also has a support for rollback. So if you are interested in making sure that once your transaction is finished, that you can retrieve it in the future, because some of your future transactions might retrieve an error, might end up in error, and you want to make sure that you can go back to the working state. There is a option to connect to a volatile memory or a persistent memory that will allow you to do that. So as I said, there are some well-known tools out there that are ready to be used, and it would be good to hear back from the community. What is your opinion on that? How useful they are? I've seen here some people that are using them, that are involved with that, but getting some more information on the tools would be helpful, for the future direction. Thank you.
David Dai from Five Home. Just a simple question. Who will maintain the open source library? And if the end users have found the problem or have a successful experience, then how can they share with other users?
So open source is viewed as a Kickstarter for the project, and there is a quite healthy community that is interested, that has a common interest in maintaining this project. This is not a ready product. And there's a difference between a system product and building blocks that you can use in your product. And if you're using this to build your product, we would then expect that you will contribute in one way or the other back to the community, because you're using that to build your own product. And this is where the open source is valuable, to kickstart certain things to be used by other people, and then through their commercial success, they would give back to the open source community, because it's part of the overall solution.
I know your point. You mean anybody can do it, right?
Yes, and the question is there a critical mass of people and companies that have joint interest in supporting something like this? And based on the few last years, there is increasing interest and support for that. So this is just to raise the awareness, seeing how it's been done and how has the system been built. Is it a system for production deployment? No, it's an example. But can I use those libraries to build a production-ready system? Yes, I can.
Okay, got it. Thank you.
Luberger, one thing that Dan didn't say is that for most of what was talked about here is they're up on GitHub. Anyone can go fork the repo. All the projects take pull requests. I'm a maintainer on FRR. We take pull requests from anyone all the time. When FRR was doing this particular work, found a bunch of problems with libyang, and the person doing the work sent pull requests, and those folks accepted it. So it's sort of the normal today's open source process is being followed, and everything that's been talked about here.
Michael Abrams here. Yeah, so I work at Deutsche Telekom. So we use this for managing both services and the home gateway, for instance, that I'm responsible for. There are other vendors that are using this in shipping products, as far as I've been told, because they needed it to make their device manageable using Netcom. So they took this and implemented all their management needs in it, and are now, but they are doing their own support for it, and it's not as much difference from Cisco or anyone else. Taking a bunch of tools and putting it in their product, and then they sell support towards the end customer. There are part of people involved in development this that are consultants that I can direct you to them, and if you want to get new features implemented and so on, they can help you with that. So yeah, I do think we're developing a healthy community around all these different projects that are tied together and creating something that is useful as a whole.
So I want to sort of maybe clarify something both for myself and for others, or get you to clarify it. The first part of your presentation talked about using open source as sort of to do network management, say, as a network operator. This is more how you used open source in FRR, the internals of a router, basically. Okay, so just there's a distinction there that, probably the.
Right. So at the beginning, I said I will give you overview of the open source tools that you can use in building a system, and then that's used FRR as an example how to use them, because I could have just left it, here's the overview of them, fine. But this gives you an additional way how they were used in an open source implementation, and you can go in there and take a look by yourself how it was exactly implemented.
Right. But I just want to make the distinction that, like, many users of these open source tools wouldn't be, say, building their own FRR or extending that. They would be using them to connect, to monitor a network and configure a network.
Yes, correct.
Okay.
Yeah.
So we are, for instance, in the process of packaging up the plugins that you use with SysRepo to implement the IETF interfaces and IETF IP and IETF systems model. So we use those standardized models. It talks to the kernel, it talks to the OpenWRT configuration subsystem, and now you can configure this OpenWRT box. You can also take SysRepo and the same plugin, and for the stuff that it talks to the kernel netlink interface, you can run this on a server as well, and you can change the IP address of the server interface or whatever. So you didn't mention much about the plugins that you also need here, but this is what implements the model. You load the model, you load the plugin, and now you can use the model that then runs the code in the plugin that actually does something.
There are guidelines how to develop your own plugins, and yes, on the previous slide, if you can just go back, please. On the previous slide, I forgot to mention that each one of these daemons has its own plugin that is being used to connect to a different centralized management daemon. And if you want to use another one, you can develop that plugin by yourself and just use it there.
Okay, Robin, just a second. While we are on topic, if you're interested in specific implementation of FRR, there's a young sub-channel on FRR Slack. You could talk directly to Renate, who's doing this work. So if you're interested, please contribute.
Okay. In fact, Robin from Huawei, in fact, I have seen this is very useful for us. Yeah, but because I have one thing I want to clarify, because I didn't maybe experience this one, because my point, I know that the Open Daylight and the Honors and also the Open Config, they also have some of these young tools. So here, the mention these tools because they can because you introduce these tools because it can satisfy the requirement to do some of this the work plug in the devices because of this, but because because I think other open source they can also support the young work, but you introduce these tools. I mean because of this open source tools can used for this purpose to implement plug-in in the devices, but other tools cannot achieve this purpose. My understanding is right or not?
You mentioned Open Daylight.
Yeah. And
Open Daylight is a controller, and in this case, it's a different layer.
Yeah.
These are your tools that your application can control to the controller and be able to export the description of the functionalities that you want your controller to control in that device.
Okay.
So if you're writing some new application and you want that application to be managed by a controller like Open Daylight,
Okay.
in that case, these are the tools that make it easier for you in order to get integrated into such a system.
Oh, okay. Understand.
So this is essentially they are
yeah, different layers. Okay.
no,
understand.
they are complementary.
Okay. Thank you.
Yeah.
Thank you. Understand.
Yeah, Michael Abramson, this makes the device manageable. It does not manage the device. So that's the distinction. And this is all created in C, but you can create the plugins in a lot of different languages. And it's made to be fairly small footprint because we're running it on home gateways. That was one of the use cases initially. And it has a very permissive license. So it's not GPL, but Apache version 2.
Rtgwg. I guess we've been looking more at we have implementations of the tooling that I talked about earlier that are both for on-device or on data source, but also for the tooling, like the management system. So I think last year at ONS, we gave a couple of presentations, a variety of open config presentations that either myself or Anish Sheikh have given, talking about building a management stack. There's examples in our tooling of building BGP model and data instances, validating them, applying them to a device. So I think we have a few different projects that tackle the other side that Chris was talking to.
Rob, if you could make them available to the...
I just sent a link farm email to the list. I will add to it.
That's great.
Thank you.
Thank you. Michael, would it be fair to ask you to prepare more detailed presentation for the next IETF about what you've been doing?
Sure. I think this one had a lot in it already, but okay, so we'll take it to the list and see what people want to hear.
Sure. Thank you. Lou?
Lou Berger, I was just going to make one comment following up on what Dan was talking about, that this can be used by others in their products. While that's interesting for the IETF, I think it's really interesting that this can serve as a reference implementation of, or reference early implementation for emerging work that we're doing here, and it can really inform our work. For example, we were talking offline about how to support different versions based on what's going on in netmod with versioning. And having that hands-on experience can really help us make sure that what we're doing here works and help identifying any shortcomings in our specifications.
Great.
Yeah, actually, I wanted to raise support for the same comment from Lou, as I heard that from some other areas that they are having in their draft development process, that they are having what they call release drafts, where they are looking together with the open source community to making sure that the draft this has been forwarded is implementable, what is good, what is bad, and use it as a corrective action. So this process that was done by the community was very helpful to validate some of the concepts and get some feedback in the in this whole draft development process, I said.
Thanks. So we're closing, right? Thanks, everybody, and we'll see you in Prague.